Hi everyone, we are Team One presenting our project focused on VR haptics. But before we can talk about gaming and haptics, we need to talk about stress. In the US, 8 in 10 people experience abnormally high stress levels. One common way to relieve this stress is through video games. In fact, half of all gamers say they experience reduced levels of stress when they are playing games. Games are great because they suck you in and immerse you in a world different than the one stressing you out. In fact, studies have shown that more immersive games can actually relieve more stress.
This is where haptics and VR comes in. Virtual reality and haptic feedback serve to help increase the immersive nature of games by transporting someone into a 360 virtual world. Current gaming haptics are quite rudimentary, mostly focusing on a single point of vibrational feedback from inside a handheld game controller. Through conversations with our need knower and preliminary research, we identified a need gap for directional, vibration-based feedback. We hypothesized that VR users will be able to differentiate between the direction of a vibrational stimuli by using an array of haptic actuators, and that this directional feedback will result in a more immersive gameplay experience. For this study, however, we are only focusing on the first half of this hypothesis, designing a testbed to prove that users can differentiate direction using a haptic array.
To do this, we built a prototype. As you can see in this video, our prototype consists of an 8x4 array of vibrational coin cell actuators that are turned on and off to draw lines across a user's palm. The LED array on the left is used to show the lines being drawn. Researchers can input the starting and ending coordinates of a line and the desired travel speed. Preliminary results suggest that this form of feedback at the palm is both detectable and discernible. However, a full study needs to be performed to validate this claim. Therefore, we propose a study in which users place their hand on the array and a researcher inputs a sequence of lines to be drawn at different speeds and directions, similar to a hearing test. When subjects sense vibration, they then select which cardinal or ordinal direction they believe the vibration is traveling in. Their answers are then compared to the actual sequence. This rigid array is only the first step in the process. We envision a final version of this device to act like a sleeve around a game controller. Directional haptic feedback could supplement casting a magic spell, removing a bottle cap, or simply being outside in the rain. Ultimately, we hope our work helps highlight the potential for directional haptics in creating more immersive VR experiences and provides a jumping off point for further research. Thank you.